welcome the next speaker, Christopher Lozinski with presentation Mqtt, also not just for Internet of Things.
Hello, and thank you for coming today. Today I'll be speaking about Mqtt. It's a message broker for pub/sub, which means publish, subscribe. It's very heavily used in the IoT industry, Internet of Things. But actually the world's largest application for Mqtt is Facebook Messenger. So it's not just for IoT. So first we'll start with a simple definition. I'll give you the longer definition, which will lose you, but by the end of the talk, the longer definition should make sense. So, a simple definition. Mqtt is a featherweight, ISO-compliant pub/sub messaging protocol. Some more details. Mqtt is an efficient, reliable, scalable, industry-standard, machine-to-machine pub/sub messaging protocol with 3 different quality of service levels, topics, retained messages, and last wills. By the end of this talk, you should understand the longer definition. So here's the basics of Mqtt. You have different processes on the network, typically on different machines. There's a publisher, there's a broker, and there's some subscribers. These things can be very scalable. The publisher sends a message to the broker, and the broker sends the message to the subscribers. There are 3 different types of messages you can send. You can send fire and forget. Hopefully it'll get there. You can send guaranteed once delivery, and you can send exactly once delivery. Most of the world is interested in the basics of the protocol for just sort of simplistic stuff. The reason it's important is it simplifies your application development. It decouples the publishers and the subscribers. So it decouples them in space. The publishers and subscribers do not need to know where they are. They don't need to know each other's IP address. All they need to know where the broker is and the topic. It decouples them in time. The publishers and subscribers do not have to be online at the same time. If you have a truck going through a network, going through a tunnel, he doesn't have internet access. He can be sent a message, he can send a message. When he comes out of the tunnel, the messages will be transferred. And finally, you have a synchronization problem. You may have a very fast server and a very slow, lightweight client, and so even if they operate at different speeds, Mqtt works very nicely. So there are 3 different quality of service levels in Mqtt. The basic one is fire and forget. You usually get through. There's at least once delivery and exactly once delivery. So say you have a temperature sensor. Every minute it sends a temperature. If you miss one of the temperatures, nobody really cares. But if you have something more reliable, like Facebook Messenger, you need to get a message, text message from somebody else. You really want to make sure you only get it once. Particularly if it's a nasty message, right? Okay, the reason I'm interested is the other part of Mqtt, which is the tree of topics. So if we look at the internet in general, we see that we have long lists on Google search or Facebook or Twitter. It's not a good way of organizing information. There's a discussion this morning about folksonomies, tags. There's the Library of Congress, the Dewey Decimal System. If you organize stuff as a tree, a basic principle in human factors is no more than 7 items in a topic. And so then you can get these very large trees, and it makes it much easier to understand. So everybody publishes to a topic. Maybe they publish to several topics. Maybe they subscribe to several topics. You can have a rich and complicated network of, the bottom row should have said publishers and subscribers, connecting up to different topics. Maybe over here we have the finance department, and not everybody can see that. We have some DevOps, chat rooms, only some people are interested. So people can subscribe to the topics they're interested in, or the machines can subscribe. I will give you my example of why I'm interested in it. So what I do professionally is I catalog Python videos. So here we have some of the best Python videos from EuroPython. Just the lightning talks. You go to YouTube and they get divided up. They get 12 talks in a 1-hour video. and you can't find them, you can't search for them, you can't vote for them. So I slice them up, and then people can just scan through 3 hours of EuroPython, they can just scan through the descriptions, 4 hours of PyCon US, they only watch the ones. And I have a larger part of the network where I organize them as a tree. Let's see. So here we have the best lightning talks overall. There's over 1,000 videos in here. But if you go down, it needs to be organized. So here we have the data science ones. Here we have machine learning, parallelism, multi-threading, multi-processing, people and communities. And you can see there are different categories. And you can actually jump down. Here's an excellent talk from, you can jump down into one of these talks, Data Science Without Borders. And you can see where you are in the tree. So if I just had like Slack as a chat, it wouldn't work. What I'd like to do is have one chat room for every video so people can discuss that video. And so I have a tree of videos, and so I have a tree of sorry. And so I need a tree of, just a second here. Oh, it works in the, oh, it doesn't work in this browser, sorry. So anyhow, so hierarchy is great for managing complexity, and MQTT gives me that ability to manage things as a tree. It can also work as a simple database. The more advanced MQTT brokers will give you a proper persistent hierarchy, but you can just think, it has something called retained messages. So for any topic, the most recent message can be retained. Somebody connects to it, it can get that value. You can think of it as a tree of key value stores. Quite useful. There are lots of different features you might want. The default MQTT broker, MQTT was started in 1999 by IBM for tracking oil pipelines over very expensive, slow satellite links. And so then they spin it off into the PAHO Foundation, and the Mqtt broker is written in C. That's the default one that everyone uses. It's complicated. I've tried installing it. Okay, you can install it. It's Linux. You have to configure text files. Way too painful. Much easier to use an online broker. I tried my QTT Hub. I tried Flespy. Both quite painful to use. Cloud MQTT, very nice user interface. I'll show it to you later. So that's the easiest way to get started. They have like, for 5 users, you get it for free. So really easy way to get started. Actually, even before then, Mqtt, the default one, has some free servers. But as we'll show you, other people you don't want to use that for production because other people can write to you. If you want scalability, these things do. Erlang is a very parallel programming language, Golang. They've got several in Erlang and Golang. The Erlang brokers are much older, and so they have a lot more features. They tend to have the good persistence mechanisms. The Golang is sort of a hotter language now, so a lot of interest in that. Akamai has a very interesting solution where they distribute the brokers all across the world. So it looks to you like it's a single tree, but it's really properly distributed so you can get very high performance. And then, the various ones that give you persistence. You may want to choose a broker by language. So in Python world, HBMQTT, if you actually want to hack it, better not to hack the brokers. C is the Mqtt, the default one. Erlang is the older ones, which have a lot more features. They're expensive. Not clear if you need all those features. Golang are the hot new ones. Node.js, a lot of interest in that. Java, and then you've got some that just run on very small sort of IoT devices. MQTT client library. So choose whichever language you want. And because it's a standard, it's an ISO standard, all the client libraries work with all the MQTT servers. Why not do HTTP? I don't want to go too much into the details and numbers, but they solve very different problems, right? So the idea in MQTT, you just have a little bit of data, you want it to be really inexpensive network bandwidth. HTTP, you're downloading a whole document, you're downloading CSS, you're downloading images, you don't really care in which order. For MQTT, you do care in the order in which you receive the messages for many applications. So very different, but the bottom line is MQTT takes a lot less battery, you get a lot more messages per minute, you get less battery usage, a lot less battery usage per message. And MQTT also works very well in the truck situation where your devices are asleep and awake and intermittently connected with HTTP. Hard to send them a message to a device that's not there. Here's a nice graphic of a person doing the performance ones. He ran this on a 6-core server. It had a nice graphic, so I chose. He ran it on a 6-core server. He also ran the testing software on the 6-core server. So I guess he gets about 20,000 messages. You can probably get 100,000 messages a second through MQTT. That's with a single server. There are a number of clustering servers that'll scale to as many as you want. Wish I had this many messages on my servers. Of course, the big one is Facebook Messenger. How many users Facebook has? It's a standard, Oasis. So IBM released the standard to the public. They have the Eclipse Foundation, and it became an Oasis standard. I haven't heard of Oasis, some standards body, but it's now an ISO standard. And so presumably all of these work together. There are actually 2 standards. There's the 3.1, which is very simple and lightweight. And of course, like everything else in software, there's a 5.1, which has a lot more complexity. And, okay. I like simple. Okay, so back to the definition. Hopefully, this time it makes sense. MQTT is efficient, reliable, scalable, industry standard, machine-to-machine, hub-sub messaging protocol with 3 different quality of service levels: topics, retained messages, and last wills. Forgive me, I didn't have a slide on last wills. The idea of a last will is you can connect to the MQTT server, to the broker, and you can say, when I die, when I disconnect from you, please tell the world that I'm dead. And this is the message to send them, and this is the topic on which to do it. So you can be notified if some device goes offline. Okay, so there are a bunch of interesting links here. Awesome MQTT. So awesome lists are curated lists on GitHub that you can contribute. They have different rules for how to do it. They have a list here of all the different brokers, which is very interesting. They'll have links to the clients. And there are clients not only from... The Eclipse Foundation has a set of clients called PAHO for a whole bunch of different languages. We'll look at that in a minute. But there are also some other ones. And so those will be listed here. You need a tool, so when you're just testing your server, it's nice to have some user interface, which I'll show you in a minute, to test your server and just make sure test your broker and make sure everything's working. So they have a list of those here. I use, I'll get to the one I use in a minute, but I'm looking for one for the cell phones, right? So if you have a problem on your cell phone, you can just quickly take a look and what's happening. So, okay, awesome, MQTT, lots of good stuff in there. I use this Mqtt Explorer. Well, actually, I'll just show you the demo here. Excuse me. Can I get a hand holding this microphone, please? Okay, so here we have Mqtt Explorer. This is one of those user interfaces. Before you start programming, you want to make sure that your your broker is working. And so there are 2 free brokers that actually come pre-installed when you run Mqtt Explorer. This will run on Windows, Mac, and Linux. And so you can actually it gives you some parameters. You have to tell it what the name of the broker is, what the topic is, the port number, and then you connect, and then you can see all of your topics. And the reason you don't want to, and so it's easy for us to sort of look at the history of a particular topic. I don't know if there's any history on this one. It's also very easy for us to post on a particular topic. One-handed typing. And then you can see in the history, you can see the history, you can see the hello message. So it's really easy this is a tool. It's very difficult to find good tools that manage trees. So this one does manage the tree correctly. You can browse the tree, you can look at the history. It's good to sort of poke around and see. It's much easier to do this than to try to do it from a developer perspective. Close this guy out. cloud@mqtt.com. So this is a very simple, so I looked at, so the easiest thing to do is just let's start with a cloud, because you just have a web form and you don't have to mess with all this file system configuration and HTTPS and all that stuff. And so this gun looks quite easy, so I kind of recommend it. And you can, they give you this, these are the guys, this is cloud@mqtt.com. They give you 5 free users. And you basically get a simple thing with your port, different ports, and your passwords and all that. So it's really easy to use this and connect it up. Although I have not been able to get this to work with the Mqtt Explorer, so I don't quite know what to make of that. What else do we have here? They're the PAHO libraries. Come on. Components. So you can see here all the different libraries. The Python one that I've worked with some, so there are 2, typically you can click into the Python, you can click into the JavaScript. The Python one is based on threads, and so that's really quite easy to use. You just send queues to messages. There's also IMQTT. So how many people are using Ipython? Okay, so everybody who's not using Ipython, you should use it. It's the basis of Jupyter Notebooks. It gives you a whole bunch, it's like the Python interpreter, REPL, read, eval, print loop, but it just gives you a whole bunch of different functionality. At this year's EuroPython, there's an excellent talk on Ipython. It's not my job to go into it. There's so much great software on the web that people aren't using, but that's one. And actually, I'm embarrassed too, because I've only started using it recently, so I don't feel too bad, but it should be in everybody's toolkit. And so then there's a library called IMQTT. So I really like this one. They do my whole demo for me, and it just shows you how to connect and how to send a message and how to receive a message. There you go. Don't have to do anything here. And if you go down, you can see it's really easy. It's really easy to use. So basically, you enter the MQTT shell, and then you connect to it. You build a TCP client and connect to a server. You send a message. You send an acknowledgement. You can receive a message. You can send an acknowledgement when you receive it. I mean, really quite easy. One of the reasons I went to MQTT is because async I/O, big improvement over what we had earlier, but really it's very painful. So MQTT just makes it just a very simple interface to send messages to other machines. Let's see what else. Libraries. Okay, so you feel free to contact me, pythonlinks.info. If you're interested in knowing about the newest, the best Python lightning talks, you can follow me on Twitter. Actually at pythonlinks.info, you can sign in, I'll send you an email about them. And almost 20 minutes, we have some time for questions if anybody has any. Thank you.
Any questions?
Hi, thank you. What exactly did you have in mind when comparing MQTT to SNL?
So I've actually taken a lot of look at there's a larger concept called communicating sequential processes. And so communicating sequential processes are, and they're actually implemented in Golang, but they go way back. And the idea there is that you have just a sequential process, and when it's done, it sends a message to a queue to some other process. So it's really easy to understand, really easy to program. Then you have this JavaScript stuff with callbacks, which is hugely painful, and there's async I/O, which, do you include the await, do you not include the await? It's like, when do you use it? It's just not simple. It's too complex, at least for my brain. So it's evidently a huge improvement over what was there previously, and it's what everybody uses. But this is, as you saw from the APIs, it's just so easy to use this stuff. Politically incorrect to speak against async I/O, I know that. Okay. It's also, async I/O is brilliant for large corporations, right? So my later talk on ZODB is how there's a difference between the technologies you choose as a large corporation and as a small corporation. As a large corporation, when you have dedicated developers who can take the time to think differently, async I/O works great. But if you just want to keep it simple, this is really simple. Even I can do this.
Simple question, because you mentioned about the brokers.
Yeah, repeat your question so it's recorded. So.
Hi, you mentioned something about the brokers. You put the list of all brokers, the most of the popular brokers, and which broker you are using on the production?
So,
currently for development, I'm using Mqtt, and I'm using their demo servers. I've installed like several other ones. Let's see, which one was it? Emitter.io. I have a lot of experience with Emitter.io, which is one of the Golang ones. I sort of went for the sexy language Golang, but not quite happy with it. What happens is it depends on what your values are, right? And so my current thinking is I just want something simple and reliable that everybody else has used. So if I wanted like persistence or a lot of very advanced functionality, then I'd go generally for the Erlang ones because they're older and they have a lot more functionality. I tried installing one the other day. I gave up installing it. It was so painful. Mqtt is much easier to install. I have installed it. If you need a lot of performance, then the Golang ones are good. So, and again, the Mqtt is just kind of the default one to start off. But so the simplest thing is start off with the free Mqtt ones online. The second thing is go to an online one so you don't have to configure a thing. And then after that, it depends upon, do you need functionality? Do you need performance? Do you need reliability? It depends upon your needs. And the great thing is you do have a lot of choices, right? And in the client libraries, you have a lot of choices. So in the fact that it's an industry standard just makes it really easy to jump. Try one, try the other. Spend all your time trying different ones.
So I noticed you had RabbitMQ on one of your slides, and I was wondering how would you compare MQTT with AMQP?
I heard about AM.
I can do a comparison if you like.
Yeah, I did hear AMQP a little while ago. I'm not quite sure what it is. Evidently, RabbitMQ has like a binder that makes it look like an MQTT tree. I don't know the details. There's just so many choices out there. Yeah. Next question in the back there. Thank you so much.
I'm willing to answer this one.
Go ahead.
If it's appropriate. I used MQP a lot in production for web systems, and I also do some IoT where I use MQTT quite a lot. MQP has many more features than MQTT 3.1. Many of the things that you see going into MQTT 5.0 is very kind of inspired by MQP. For example, concept for request response. So you could do that, not just pub/sub type things. Metadata into your messages, for example. But in general, so that's like the technical stuff. And then on the more what you would do with what, there's like cultural difference. MQP is very established in web, cloud environments, all the tooling and stuff like that. Whereas MQTT is very IoT focused in the practices and so on. With MQTT 5, it's very similar technically, but practices are not yet kind of established in the web.
Let me add another word there.
So the other question is between the MQTT 3.1 and the 5.0 protocol. And so in HTTP, you have headers with all kinds of additional information, and one of the big things in the MQTT 5.1 is you have these headers with additional information. So if you just want to send a little bit of data, stick with 3.0. If you want more complexity for the headers, then 5.1. There are a lot of different details there.
Thank you.